2.18 Anti-lock braking systems, ABS. ABS is a computerized system that keeps your wheels from locking up during hard brake applications. ABS is an addition to your normal brakes. It does not decrease or increase your normal braking capability. ABS only activates when wheels are about to lock up. ABS does not necessarily shorten your stopping distance, but it does help you keep the vehicle under control during hard braking. 2.18.1 How anti-lock braking systems work. Sensors detect potential wheel lockup. An electronic control unit, ECU, will then decrease brake pressure to avoid wheel lockup. Brake pressure is adjusted to provide the maximum braking without danger of lockup. ABS works far faster than the driver can respond to potential wheel lockup. At all other times, the brake system will operate normally. 2.18.2 Vehicles required to have anti-lock braking systems. The Department of Transportation requires that ABS be on. Truck tractors with air brakes built on or after March 1, 1997. Other air brake vehicles, trucks, buses, trailers, and converter dollies, built on or after March 1, 1998. Hydraulically braked trucks and buses with a gross vehicle weight rating of 10,000 pounds or more built on or after March 1, 1999. Many commercial vehicles built before these dates have been voluntarily equipped with ABS. 2.18.3 How to know if your vehicle is equipped with ABS. Tractors, trucks, and buses will have yellow ABS malfunction lamps on the instrument panel. Trailers will have yellow ABS malfunction lamps on the left side, either on the front or rear corner. Dollies manufactured on or after March 1, 1998, are required to have a lamp on the left side. As a system check on newer vehicles, the malfunction lamp comes on at startup for a bulb check and then goes out quickly. On older systems, the lamp could stay on until you are driving over 5 mph. If the lamp stays on after the bulb check, or goes on once you're underway, you may have lost ABS control. In the case of towed units manufactured before it was required by the Department of Transportation, it may be difficult to tell if the unit is equipped with ABS. Look under the vehicle for the ECU and wheel speed sensor wires coming from the back of the brakes. 2.18.4 How ABS helps you. When you brake hard on slippery surfaces in a vehicle without ABS, your wheels may lock up. When your steering wheels lock up, you lose steering control. When your other wheels lock up, you may skid, jackknife, or even spin the vehicle. When you brake hard on slippery surfaces in a vehicle without ABS, your wheels may lock up. When your steering wheels lock up, you lose steering control. When your other wheels lock up, you may skid, jackknife, or even spin the vehicle. 2.18.5 ABS on the tractor only, or only on the trailer. Having ABS on only the tractor, only the trailer, or even on only one axle still gives you more control over the vehicle during braking. Brake normally. When only the tractor has ABS, you should be able to maintain steering control and there is less chance of jackknifing. But keep your eye on the trailer and let up on the brakes if you can safely do so, if it begins to swing out. When only the trailer has ABS, the trailer is less likely to swing out, but if you lose steering control or start a tractor jackknife, let up on the brakes if you can safely do so until you regain control. 2.18.6 Braking with ABS. When you drive a vehicle with ABS, you should brake as you always have. In other words, use only the braking force necessary to stop safely and stay in control. Brake the same way, regardless of whether you have ABS on the bus, tractor, the trailer, or both. As you slow down, monitor your tractor and trailer and back off the brakes if it is safe to do so, to stay in control. 2.18.7 Braking if ABS is not working. Without ABS, you still have normal brake functions. Drive and brake, as you always have. Vehicles with ABS have yellow malfunction lamps to tell you if something isn't working. Vehicles with ABS have yellow malfunction lamps to tell you if something isn't working. As a system check on newer vehicles, the malfunction lamp comes on at startup for a bulb check and then goes out quickly. On older systems, the lamp could stay on until you are driving over 5 mph. If the lamp stays on after the bulb check, or goes on once you are underway, you may have lost ABS control on one or more wheels. Remember, if your ABS malfunctions, you still have regular brakes. Drive normally but get the system service soon. 2.18.8 Safety Reminders. ABS won't allow you to drive faster, follow more closely, or drive less carefully. ABS won't prevent power or turning skids. ABS should prevent brake-induced skids or jackknives, but not those caused by spinning the drive wheels or going too fast in a turn. ABS won't necessarily shorten stopping distance. ABS will help maintain vehicle control, but not always shorten stopping distance. ABS won't increase or decrease ultimate stopping power. ABS is an add-on to your normal brakes, not a replacement for them. ABS won't change the way you normally brake. Under normal brake conditions, your vehicle will stop as it always stopped. ABS only comes into play when a wheel would normally have locked up because of overbraking. ABS won't compensate for bad brakes or poor brake maintenance. Remember, the best vehicle safety feature is still a safe driver. Remember, drive so you never need to use your ABS. Remember, if you need it, ABS could help to prevent a serious crash. 2.19 Skid Control and Recovery. A skid happens whenever the tires lose their grip on the road. This is caused in one of four ways: overbraking, braking too hard, and locking up the wheels. Skids also can occur when using the speed retarder when the road is slippery. Oversteering, turning the wheels more sharply than the vehicle can turn. Overacceleration, supplying too much power to the drive wheels, causing them to spin. Overacceleration, supplying too much power to the drive wheels, causing them to spin. Driving too fast. Most serious skids result from driving too fast for road conditions. Drivers who adjust their driving to conditions don't overaccelerate and don't have to overbrake or oversteer from too much speed. 2.19.1 Drive wheel skids. By far the most common skid is one in which the rear wheels lose traction through excessive braking or acceleration. Skids caused by acceleration usually happen on ice or snow. Taking your foot off the accelerator can easily stop them. If it is very slippery, push the clutch in. Otherwise, the engine can keep the wheels from rolling freely and regaining traction. Rear wheel braking skids occur when the rear drive wheels lock. Because locked wheels have less traction than rolling wheels, the rear wheels usually slide sideways in an attempt to catch up with the front wheels. In a bus or straight truck, the vehicle will slide sideways and spin out. With vehicles towing trailers, a drive wheel skid can let the trailer push the towing vehicle sideways, causing a sudden jackknife. See Figure 2.19. 2.19.2 Correcting a drive wheel braking skid. Do the following to correct a drive wheel braking skid. Stop braking. This will let the rear wheels roll again and keep the rear wheels from sliding. Countersteer. As a vehicle turns back on course, it has a tendency to keep on turning. Unless you turn the steering wheel quickly the other way, you may find yourself skidding in the opposite direction. Learning to stay off the brake, turn the steering wheel quickly, push in the clutch, and countersteer in a skid takes a lot of practice. The best place to get this practice is on a large driving range or skid pad. 2.19.3 Front wheel skids. Driving too fast for conditions causes most front wheel skids. Other causes include lack of tread on the front tires and cargo loaded, so not enough weight is on the front axle. In a front wheel skid, the front end tends to go in a straight line regardless of how much you turn the steering wheel. On a very slippery surface, you may not be able to steer around a curve or turn. When a front wheel skid occurs, the only way to stop the skid is to let the vehicle slow down. Stop turning and/or braking so hard. Slow down as quickly as possible without skidding. Subsections 2.17, 2.18, and 2.19 Tester knowledge. 1. Stopping is not always the safest thing to do in an emergency. True or false? 2. What are some advantages of going right instead of left around an obstacle? 3. What is an escape ramp? 4. If a tire blows out, you should put the brakes on hard to stop quickly. True or false? 5. How do you know if your vehicle has anti-lock brakes? 6. What is the proper braking technique when driving a vehicle with anti-lock brakes? 7. How do anti-lock brakes help you? These questions may be on the test. If you can't answer them all, reread subsections 2.17, 2.18, and 2.19.